So remember, perfusion is the ability to move blood through the capillaries of the organs in a manner that meets their demands. This requires homeostasis between the pump, the pipes, and the fluid. Let's introduce some terms that describe the heart pump's role in perfusion homeostasis: rate and rhythm, preload and afterload, stroke volume and ejection fraction, and cardiac output and cardiac index. The heart rate is the number of beats per minute. The stroke volume is the volume of blood pumped per beat, let's say about 70 milliliters. So now that we've discussed the stroke volume and the heart rate, we can talk about cardiac output. Cardiac output equals the stroke volume times the heart rate. And cardiac output is the volume of blood pumped over 1 minute, about 5 liters. Cardiac index is cardiac output adjusted for weight and height. An elephant has a much greater cardiac output than a mouse, but if you divide the cardiac output by their surface area, they should both have a cardiac index between 2 and 4. Since we are discussing normal human physiology, we use cardiac output. Cardiac index is used in ICU situations. Preload is the volume of blood in the left ventricle before contraction, end diastolic volume. Afterload is the volume of blood in the ventricle after contraction, end systolic volume. So remember, preload is the volume of blood in the ventricle before the contraction, end diastolic volume. And afterload is the volume of blood in the ventricle after the contraction, end systolic volume. Stroke volume is the volume of blood pumped during a single beat, the preload minus the afterload. The ejection fraction is the percentage of blood pumped during a single beat, the stroke volume divided by preload. So we can measure how much the heart pumps during each beat in 2 ways: by measuring the stroke volume or by measuring the ejection fraction. Measuring the ejection fraction can be easily done in an echocardiogram, and this is how we may diagnose congestive heart failure. An elephant has a much larger stroke volume than a mouse, but similar ejection fractions. A healthy heart has an ejection fraction of about 70%. Some factors that contribute to ejection fraction are the strength of the heart muscle, how much preload enters the heart, and systemic vascular resistance. A healthy heart is like a spring. The Frank-Starling law of contractility is the same as Hooke's law of springs. When a spring is stretched, it exerts a force. More stretch equals more force. The Frank-Starling law states that the more the heart fills, the stronger the force of contraction. Less fill results in less contractile force, and more fill results in more contractile force. So just like springs, if the heart is overstretched, it loses its capacity to return force. Healthy hearts are like a spring. More filling results in more contractile force. And if the heart is overstretched, it loses its capacity to return force. More filling results in less force. Here we see a normal heart where more filling it results in more force. But in dilated cardiomyopathy, more filling ends up resulting in more failure. Congestive heart failure is failure of the pump. Congestive heart failure is failure of the pump to adequately perfuse the organs. This includes removing fluids as well. The right side of the heart collects blood from the body. So if there is right-sided failure, fluid collects in the body. This is edema. There are other causes of edema too. Edema can be mild and localized, like a pitting of the feet. Edema can be severe and involve the entire body. This is anasarca. Edema and anasarca have many other causes besides heart failure, but heart failure is one of the causes. The left side of the heart collects blood from the lungs. So if there is left-sided failure, fluid collects in the lungs. This is pulmonary edema. There are other causes of edema too. Pulmonary edema can be mild and result in crackles on auscultation of breath sounds. Pulmonary edema can be severe and result in shortness of breath and wet breath sounds. There are other causes of pulmonary edema, but heart failure is one of them.